Okay, so once again, please go to student.desmos.com, type in this code, or use the link that I provided in the chat to go to this lesson. And we're going to continue to talk about and to do related rates. And then we're going to go ahead and do some of these questions today. And hopefully we could get through some of these questions a little bit faster. I tried to go a little bit faster in the first period, but I wasn't able to. So we only got through about a couple of questions, but I have, let's see here, 2, 4, 5, 6 questions for us to try to practice. And then what I'm going to do is I'm going to release this after our lesson, and you guys can try to solve all these problems kind of on your own. Whatever we don't get to, you guys could try to solve those on your own. Okay, couple of announcements really quick. So just so everyone knows, don't forget that I am releasing the quiz tomorrow. Okay, so I'm releasing the quiz tomorrow on Delta Math. It will only entail particle motion and related rates. Okay, so the quiz will only be particle motion and related rates. You're going to have 7 questions, and you're going to have about half an hour, 30 minutes to do it. So you can do it anytime tomorrow to Friday night. And then once you start it, you'll have half an hour to complete it. Okay, so you have 30 minutes to complete that. Also, next week, I don't know if you guys know this, but next week, Thursday is a minimum day, which means that Thursday's schedule is the same schedule as Wednesday. So that means Wednesday and Thursday will be minimum, those short 20-minute periods, which everyone should know that's just not enough time to do hardly anything. And so because of that, that means that next week, our exam, our FRQ exam will be on Monday. So I apologize, but there's really no other way of doing it, because if you think about it, if I try to do it on Thursday, that only gives you 20 minutes to try to do the entire FRQ if I start right away. And so I just don't think that that's enough time for you guys to get it done. And so what we'll do is we'll do it on Monday. You'll have your FRQ on Monday. The multiple choice portion of it will still be on Delta Math, and that'll still be Thursday, Friday. So it'll be open Thursday, and then you could get it done anytime till Friday midnight or Friday 11:59 p.m. So that will still be Thursday, Friday, the multiple choice portion of it. However, the FRQ portion of it will be on Monday, just to let you know. Okay, so that will be on Monday. So plan on that being Monday. All right. So that being said, let me go ahead and finish taking roll here. If you haven't already signed up or gone to desmos.com or student.desmos.com and typed in this code, go ahead and do that. I do see that there's quite a few of you who are already here. So let me go ahead and look and see. It looks like there's about 23 of you guys here. Okay, so in any case, let's go ahead and get onto today's lesson. And we're going to mainly be talking about related rates. How do we solve related rates today? So today's our last day of related rates. On Monday, we'll talk about linear approximation and L'Hopital's rule. So we'll do that on Monday. And then on Thursday and on Wednesday and Thursday, those are just short periods. So we're not going to do much on those days, just to let you know. Everyone should definitely try to finish up all 3 of these packets this weekend. If you finish up all 3 of these packets this weekend, you should be prepared for the test on Monday. So once again, the test will be on, or the FRQ portion of the test will be on Monday, just because Thursday is a minimum day and Friday's no school at all. So even though there's no school on Thursday minimum day on Thursday and no school on Friday, the multiple choice portion of the test will be on your own time Thursday and Friday, and you can take it anytime Thursday or Friday up until 11:59 Friday. And then it'll just be the same as we always do it, like a half an hour multiple choice exam on Delta Math. Okay, so here we go. Here's our first question. Let's go ahead and see if you guys can answer this question here. And I'll let you guys try to do this all on your own, and then I'll come back to it and I'll try to walk you through it if you need some help. Okay, let me just say that from the pictures that I see, you guys are doing a great job with your pictures, but if you do not draw the correct picture, I will say that you're probably not going to be able to solve the rest of this problem. If you have an incorrect picture, if your step number 1 is wrong, you will not be able to get the correct answer. And pretty much everything else is just going to be wrong from this point on out. Okay, so let me help you out a little bit, and I will help you with the picture. And I will say that you guys did a great job. A lot of the pictures that I see are exactly right. However, there might be a couple of things that you might not understand. And so let me go ahead and make sure that everyone is at least starting off correctly. if everyone's starting off correctly, then at least you should be able to get to the end and get the correct answer. And so here we go. First thing is, we know that jet A and jet B are exactly 100 miles, or jet A is exactly 100 miles north of B, and so that has to be a vertical line. So if you didn't draw that jet A is exactly 100 miles north of jet B like that, you might not have the correct picture, just so you know. Okay, so that's the first thing, is we want to know that jet A and jet B are exactly on the same, we would say the same, what's that, longitude or latitude? Longitude, yeah, longitude. Okay, so in any case, they're exactly 100 miles away from each other. And then jet A is going to go 768 miles due east, and then jet B is going 900 miles west, right? So, and we could say due west, or exactly to the west. And so, and what we're interested in, and we know that this is 100 miles, and what we're interested in is this distance between them. We want to find this distance between them. And what you could do is draw a line from one jet to the other jet, because this is after 1 hour. So after 1 hour, hopefully everyone knows, if you're going 768 miles per hour, after 1 hour, you've gone 768 miles, right? And then also jet B, if you're going 900 miles per hour, that means after 1 hour, you've gone 900 miles, right? At least on average. And so we have this, and we want to find how fast is the distance between them changing? How fast is this distance from one jet to the other jet? How is that changing? And we can draw a line there. And then what we want to do is we want to look at what are the geometric shapes that we're drawing and what's the relationship. And you could say, well, we have two similar triangles, which is absolutely correct. But that is not what I would be using, just to let you know. What I would do is I would draw that line, and rather than using two similar triangles, which we can do, I would rather just turn this into one triangle. And so the one triangle I would turn this into is a right triangle. I know that this piece right here is 100, because I know that the vertical distance here, at least vertical on a map, would be 100 miles. And what we're looking for is this red line right here. Okay, so that's what we're interested in, is that red line. Okay. But that does cause one problem. Do we know what this blue line is? Do we know how fast that blue line is changing?
We can solve for it, right?
And what would it be if we solve for it? How fast are the two?
You would just add 768 and 900, right?
Uh-huh. And so you should say that the rate that they're changing horizontally like this, right, in a straight horizontal line, is about 1,668 miles per hour, right? And which means after 1 hour, how big is that distance?
1,668.
Okay, excellent. It's 1,668 miles, right? So we know that that right there is going to be 1,668 miles after 1 hour. Okay, so that should be enough information that you can answer the rest of this question. I will get out of your hair now. I just wanted to make sure everyone had the right pictures, just so that everyone's going along the right track, because if you don't have this picture, you almost guaranteed will not get the right answer. So see if you could solve the rest of this. And then once everyone is done or close to done, I'll go ahead and finish this up with you guys. Let me just say a couple of things just to be sure that everyone's doing this correctly. You should have only two rates. So step 2, you should have only two rates. The two rates are this bottom piece, which you could label it whatever you want to. You could call it base. You could call it B for base. You could call it L for length. You could call it H for horizontal distance. You could call it A for A squared plus B squared equals C squared, because if you know you're going to use the Pythagorean theorem, you could say A. You could say X squared plus Y squared equals Z squared. You could call it whatever you want to, but we have this bottom piece, and then we have this diagonal piece. Those are the only two rates that you should be interested in. This diagonal piece is what we want to find, and this bottom piece we already know is 1,668 miles per hour. So for step 2, I would just call it A squared plus B squared equals C squared. I'd call this dAdt is the latitudinal distance. It's going to be, so this is longitudinal. So this is 1,668 miles per hour. The longitudinal distance is 100 miles, so that's not changing. That's constant. That must be a constant. Do not give that a variable, because it's not changing. And then the diagonal distance, which I'm just going to call C for A squared plus B squared equals C squared, is our distance between them. Now, once again, you could have used any letter that you wanted. You could have said base and distance, or you could have said length, or H for the horizontal, whatever you want to call it. I did see some X's. I saw some L's and some W's, and that's perfectly fine. You could call it whatever you want to. These are the only two rates that you should have for step 2, which means in step 3, the only two variables you need to have, and the two variables you must have in step 3 are C and A. If you have any other variable or whatever these two whatever you call these two, those are the only two variables you should have in step 3. And if you have any other variables other than those two, it's wrong. Okay, so I did see a lot of people say a squared plus b squared equals c squared. That would be wrong because b is not a variable. It's constant. So you'd have to say a squared plus 100 squared equals c squared. So if you didn't say a squared plus 100 squared equals c squared, that would be incorrect and you would lose points there. Okay, so be very careful. So whatever variables, of course, you can use whatever variables you want, but whatever variables you used, please make sure that you don't give this a variable, because this is not changing. This is constant, okay? So that's really, really, really important that you do it like that. So I see a lot of people use the Pythagorean theorem, which is absolutely correct. However, if you have 3 variables, it's wrong. You should not have 3 variables. You should have only 2 variables. So go back and fix it if you haven't already, okay? And then don't forget, in step 4, you should have a dc dt and a dA dt, or whatever ddt of whatever variables you have. And you need to have both of them in step 4. If you don't have both of those in step 4, you've done something wrong. Okay, so fix your step 3 if you haven't already, and then fix your step 4 if you haven't already. Okay, for the sake of time, let's go ahead and finish this up and let's see how you guys did. If you said that step 3 is a squared plus 100 squared equals c squared, that's absolutely correct. And once again, you could be using whatever variables you want for yourself. And then that's all there is to step 3. It's just, we're just going to set up our Pythagorean theorem. Step 4, we're going to differentiate this with respect to time. The derivative of a squared is 2a, but because the variable doesn't match with d dt, we have to say times dA dt, right? It's d dt of this variable. The derivative of a constant is 0, and the derivative of 2c is 2c times dc dt. So if you got this right here, that is correct. So that should be what everyone has in step number 4. In step number 5, we're just going to plug in our values. And if you plug in your values correctly, oh, by the way, you did have to solve for C by using the Pythagorean theorem. We do know that A is 1,668. What's that called? B is 100. And you did have to solve for C. And you should have gotten that, I believe that it was at 1,671, I think, approximately. Okay. So I think it was 1,671 approximately for C if you solve that. So here, if we get it, so it's going to be 2 times A, which A was 1,668, times dA dt, the rate at which A, the latitudinal distance, is changing, is going to be 1,668 miles per hour, which is equal to 2 times our C, our diagonal at that point in time was 1,671 miles, times dc dt, and we're solving for dc dt. So if you multiply 2 times 1668 times 1668, it's 5,564,448. It's equal to 3,342 miles. Divide, and we should get dc dt is approximately 1,665 or 1,665.01. And if you got that, excellent job. And if you didn't get that, that means that you made some mistake somewhere, right? So see if you can figure out where your mistake is, and then see if you can fix that. Okay? All right, so let's go ahead and try another problem here. Okay, so I am going to stop you right there. And the reason why I'm going to stop you right there is because I'm looking at your equations that everyone is writing, and nobody has the correct equation. So far, nobody has the correct equation. Most of you guys are using the Pythagorean theorem, which is not the correct equation for this problem. So if you're using the Pythagorean theorem, that's incorrect. Somebody's even using tangent, but we don't have any angles. So tangent is also not correct. There's no trig here. So there's no sine, cosine, tangent, because there's no angle. So what in the world is our relationship? So let me go ahead and help you out with this, just because for the sake of time. So let me go ahead and draw a picture. So if you can follow me over the Zoom if you haven't already, I'm going to draw a picture of this. And so let me go ahead and draw my light post. And so here's my light post or my lamp. And here it's casting some light here. I don't know if you guys can see that yellow, but it's casting some light. And then we have a man that's walking, and this man is about 6 feet tall. So he's walking, and he's about right here. And so he's walking. So there's that. And then we know that he's casting a shadow. And so his shadow is going to be like right here, let's just say, for example, and here's our light. So here's our light. Goes something like that. And then let me go ahead and just make it a little bit darker so that those of you guys who can't see that yellow will be able to see this line. Okay, so, and you might be thinking, why in the world is this question worded the way it's worded? The tip of his shadow, how fast is the tip of his shadow growing? Because the tip of his shadow is different than his shadow. So think of it this way. If the light was moving, okay, so let's just say that this light was not stationary, it's some kind of adjustable light or something like that. If this light is moving, his shadow is going to grow, right? The rate that his shadow grows is different than the rate of the tip of his shadow. Because if his shadow, let's just say his shadow is growing, I'm just going to make up a number. Let's say his shadow is growing 3 feet per second, right? Well, how fast is the tip of his shadow growing? Well, the tip of his shadow is growing 3 feet per second. But what if the man is moving? What if the man is walking at 5 feet per second? If the man is walking at 5 feet per second and his shadow is growing at 3 feet per second, well, how fast is the tip of his shadow moving if the man is moving and the shadow is growing? Well, the tip of his shadow would be growing at a rate of whatever the speed of the man is plus the rate of the shadow. So the tip of the shadow is different than the shadow itself. So that's why they word it the way they do. Let me give you another example. If I'm standing on a train and the train is going 60 miles per hour and I'm standing still, but the train is moving 60 miles per hour, does everyone understand that I am moving 60 miles per hour if I'm standing on that train? Even though I'm not moving, right? I could be standing still. If the train is moving 60 miles per hour, my body is also moving 60 miles per hour, right? Now, if I'm holding a ball in my hand, right? I have a ball in my hand and I'm just holding it. Well, that ball is also going 60 miles per hour. Now, if I throw that ball forward, and let's say I throw that ball forward at 30 miles per hour, well, how fast is that ball moving now? That ball would be moving 90 miles per hour, right? It would be moving 90 miles per hour. So even though it might not seem like it to you, because it's relative to your speed, we know that that ball would actually be moving 90 miles per hour. So if there was someone standing outside of the train, there was someone standing on a sidewalk, and the train's going 60 miles per hour, and we're going toward him, and I throw that ball at him, right? And he's just standing there, and I throw it 30 miles per hour. When that ball hits him, it's going to hit him at 90 miles per hour, right? So that ball would that would knock him out. He would be like, "What the heck just happened?" Right? So if you're moving at that speed and you throw it forward at 30 miles per hour, that ball is actually moving at 90 miles per hour. So that's kind of what's happening with the tip of this shadow. If the man is moving and the shadow is growing, which is what's happening, the tip of his shadow is growing at a rate that's with respect to both of those. Okay. All right. So that being said, here's where it gets a little tricky is in drawing this picture. I know that this man is right now 40 feet from the base of this light post, and that's changing because the man is moving. So I'm going to give it a variable. Anytime something is changing, we give it a variable. Okay. I also know that the shadow is changing, but I don't know anything about the shadow right now. Okay. So I do know that that's changing. And then what this question is asking me is, what's the tip of this shadow? So this right here, I'm going to give it a capital T for the tip. So the tip of the shadow is also changing, and it's changing at a rate of both of those added together. So here, let me ask you, can anyone tell me how big is T? If you can figure out how big T is, then you know what the equation is that you need to use in step 3. So how big is T? How far is the tip of his shadow from the base of this light post?
It would be M plus S, right?
So it would be M plus S, but what's S?
We don't know yet, right?
Right, we don't know, but can we figure it out? So that's what we have to do. Just given the information that we have, can we figure it out? And so what other information do they give us? So let's go ahead and start marking that. So I do know that this man is 6 feet tall, right? And that's constant. I'm not going to give it a variable because that's constant. I also know that this light post is 15 feet tall, and that's also constant. That's not changing, right? That's staying the same. So I'm just going to go ahead and write 15 feet right there. Is that enough information, knowing that, to figure out what T is? And how would we do that?
Are they similar triangles? So
We
when we
do
just
have
give
similar
these
triangles.
proportions?
Perfect. That's exactly it. So and here's the key. We have to draw a new line here, which we didn't have before, which is hopefully everyone agrees is parallel. Those are going to be parallel to each other. The ground and this horizontal line will be parallel to each other. But guess what? We just created two 90-degree triangles. And so these triangles must be similar because these angles are the same, these angles are the same. So using the AA similarity postulate, we could say that these two triangles must be the same, right? Or similar. They must be not the same, but they must be similar. So now I'm gonna go ahead and I'm not gonna call this bottom piece, this part of the triangle, I'm not gonna call that M anymore. I'm gonna go ahead and move it to this top part of the triangle, and I'm gonna call this top part of the triangle, I'm gonna call that 40 feet. So now I know the bottom of this triangle here, this green line, I know that that's 40 feet all the way to the top of the man's head. Okay, so I know that that's 40 feet. Could we figure out the length of this side of this triangle right now? Do we know how big that is?
9.
It's 9. Perfect. So that's 9 feet because we know that the man is 6 feet tall. So if the man is 6 feet tall, we have to subtract that from the 15-foot height. So we know that that's going to be a 9-foot height. So now look, we have this triangle here, which is a 40, that has a 40 base with a 9 length on the side. For the legs of the triangle, it's a 9 and 40. And then for this right here, it's 15. And I'm trying to figure out what T is. Is that enough information for me to figure out what T is?
You would set up a proportion between them, right?
Perfect. And so that means that this S right here is not necessary. So we could actually get rid of it. So let's not add any extra variables if we don't need to. And so what we're interested in is just this M, this T, this 9, and this 15. And we could set up a proportion. And that's exactly right. And so let's go ahead and set up a proportion. And there's two ways you could set up your proportion. You could say that T is to 15. So you could say here, T is to 15, right? So this bottom leg of the big triangle is to the left leg of this big triangle, as the bottom side of the small triangle is to the left side of the small triangle. You could say T to 15 is 40 to 9, or you could set it up like this way. T, the bottom leg, is to the bottom leg. So you could say T is to 40 as the left side of the big triangle is to the left side of the small triangle, as 15 is to 9. So I don't know if you guys know, but these are the same. These are equivalent proportions, right? They're going to be equivalent when you cross multiply. It's going to allow us to solve for T, and they're going to give us the same answer. And so you could set it up either the bottom base is to the bottom base as the bottom leg is to the bottom leg as the left leg is to the left leg. Or you could say the bottom leg is to the left leg as the bottom leg is to the left leg of each respective triangle, right? So you could set up either way, however you want to set up. It's preference, however you want to set up. So that should be enough information now for you to solve the rest of this. And by the way, in step 3, don't use either of these. In step 3, you need to use variables. Okay, so step 3, make sure you're using M and T. Make sure you're using M and T. Those are our 2 variables. Okay, so in step 3, you should be setting up a proportion using M and T, and then see if you could solve the rest of this on your own. And use a capital T because we use little t for time. We're using little t for time. So DDT is little t, so use a capital T. So don't use the same variable for something different, okay? So if you have 2 different things, make sure you're using 2 different variables, right? So if you're gonna use T, make sure it's a capital T for the tip, because lowercase t is time. And I do wanna say this one thing. If you think that related rates are hard, you are in the same boat with the vast majority of all calculus students, okay? So most calculus students feel that related rates are hard, okay? So if you're struggling through some of these and you're like, this is tough, same with almost everyone else, okay? So there's a large proportion of people who really struggle with related rates, and you can really only get better by practicing. So if you practice through these, they do get easier, but they're hard, okay? So let me just throw that out there. If you're struggling with it and you're having a hard time, don't be discouraged. Just know that you're not alone, okay? So that lots of calculus students feel like this is tough, okay? But if you feel it's easy, good job. I mean, like, that's great. There are a handful of students that feel like, man, I love related rates and these are easy. but the vast majority of people do not feel that way.
Mr. Kim.
Yes.
So when we find t, right? Now that we found t, how do we use that to find the how fast it's going? And then once we find that, we have to add that to our initial speed of 5 seconds, right? Or 5 feet per second.
Oh no, it includes everything together because I've already added the man plus the shadow. The dt will, which is what we're looking for. So our two variables, if you guys can catch this, our two variables are going to be dt, and this is what we're looking for. This is what we're looking for. So this will give us our answer, our total answer. Just letting you know, there could be another problem where I just asked for just the shadow. And then we do have a similar triangle here with just the man and the shadow too. So those are just two different problems that we could come up with the same situation. And then we do know dmdt because that's the rate that the man is moving, which is this distance here. And they did tell us that that was 5 feet per second. So step 2 would be this. This is step 2. Step 3 would be come up with your equation that relates m and t together. And then you could solve them.
Thank you.
So if you haven't already gotten this, and I see a lot of people have this, t is to m. So the ratio we have is t is to m. And so I have both my variables as, and these are constants, so they have to be written as constants. And I'm doing the big triangle to the little triangle. So here when I set my proportion, I have to do the big triangle to the little triangle as 15 is to 9. So if you said that, that's good. And then we can reduce this to t is to m as 5 is to 3, which means t is equal to 5/3 m. So that's your equation that everyone should come up with. Okay, so that makes it easy for you to differentiate this. So now you should be able to do step 4 and 5 and finish up with step 5. Okay, so let's go ahead and finish this up. I'm just going to go ahead and go to Zoom here, if you could follow me over if you haven't already. And so the first thing we want to do is for step 4 is find the derivative of this function here. And so we're going to do ddt of this function. So we're going to say ddt of t equals 5/3 m. Sorry about that, 5/3 m. Which means d capital T of dt, and little t is time, is equal to 5/3, and the derivative of m is 1, but because the variables don't match, I have to do ddt of m or dm dt. So that's it. So the only thing we actually have to do is substitute in dm dt, which we said that dm dt is right here, is 5 feet per second. And that's weird, why did it do that? So this is going to be 5/3 times 5 feet per second. And if I give myself just a little bit more space here, solve this, I could say here that dt, d tip of the shadow, right, with respect to time is equal to 25/3. And if you said 25/3 feet per second, that is absolutely correct. So if you said 25/3, good job. If you did not get 25/3, then you did something unfortunately incorrect. Okay, so I will tell you that we do not have time to finish the next one, but I'll let you at least try to solve it. And I'm gonna actually just let you know that I'm gonna release the rest of these questions at the end of this lesson. And then I'm also gonna let you know that I never do this, but the FRQ, this week's or this unit's FRQ will be one of these questions exactly. I'm not gonna change it in any way. So it will be one of these questions that is on this lesson, but there's like 6 questions here. So we've only gone through 2 of them because of time. We just couldn't get through all of them. But let me go ahead and let you see the next question, and then I'll release all of them to you guys. And then just know that one of your answers, one of these FRQs will be this week's FRQ. Okay, just letting you know. Okay, so this should be 25/3, and we're just going to leave it as a fraction, just so everyone just knows. All right. So here you go. See if you could, how far you could get on this next problem here. So let me go ahead and release that for you. And then I'm going to go ahead and release this entire thing at the end of this lesson. And then if you want, if you come by my office hours, I don't mind giving you guys the solutions to these, but they won't be worked out. They'll just have an answer. And of course, on my FRQs, if you just give me an answer, it's worth 0 points. You must always back it up with work. Okay.
What does it mean when he says east of north?
East of north, that's a good question. So let's go ahead and look at what that means here. So here, what I would do is if I was drawing this picture, so they both are at a corner and Aiden is going to go north. And hopefully everyone knows on a map, north is up. And so I would give that a variable of A for Aiden. And we know that that's changing, right? Everyone okay with that? A is changing. And then 30 degrees or pi over 3 radians east of north means we're going to go pi over 3s from north, right? And we're going to go in an eastern direction. So then this right here would be east of north. Okay, so that would be 30 degrees east of north, if that makes sense. Okay, so in order for us to go east of north, we would do it like that. And so let me draw a better picture just so everyone has the same picture or a good picture to at least start off. Does anyone know what the relationship is between A and D and little d?
Mr. Kim, would you have to use law of cosines?
Yes, very good, Raul. So,
Yeah.
so this right here, if you don't know, d squared, the little d, is equal to a squared plus big D squared minus 2AD cosine of pi over 3. And so angle lowercase d is pi over 3, that's constant. Don't write it as a variable if it's constant and it does not change, which it doesn't. Okay, so please make sure that you always write it as a constant if it's constant. So that's step 3, by the way. I'm just giving you step 3.
Mr. Kim, when do we know to use that?
You have to use the law of cosines if the triangle is not a right triangle. And so there's nothing that guarantees that this is a right triangle. If it were a right triangle, you could use Pythagorean theorem or sine, cosine, tangent. You could use any of those. But if it's we call it an oblique triangle, a triangle that's not right, then you have to use the law of cosines. So I don't know if this is a right triangle. In fact, more than likely, it's not a right triangle, which means we have to use the law of cosines.
Mr. Kim, would we have to find a derivative of this relationship here in order to solve the problem?
Yes, but I will say we can simplify this a little bit because cosine of pi over 3, if you guys don't know, is a half. So then this is going to be d squared equals a squared plus capital D squared, right? So minus AD, because half of 2 is 1, right? So this is actually our actual equation that we're dealing with, which that makes it a little bit easier, I hope. By the way, I did not finish step 1, which is what you still have to do is you still have to say, what are these values? What's A, what's D, and what's little d, right? So that would be step 1. Step 2, state all your rates, right, with respect to t. So we have d a dt, we have d capital D dt, and then we have d lowercase d, not b, d, dt. Okay, so can you fill that out and then differentiate that with respect to time, plug in your values, and then solve if you can. Okay, for the sake of time, we're not going to be able to finish this, but let me give you the solution to this. So just so that you guys can have it to check your answer. If you got 105 over radical 21 feet per second, that is correct. Go ahead and write that down. I'm going to give you the answer to the next question. The answer to the next question, which is the clock question, is negative 11 pi rad 3 over 60 radical 37. The answer to the next question, because I'm going to release all of these to you guys, is the pool problem. It's going to be 5 feet per 88 minutes or 0.057. And then there's one last question, which is the lantern problem. And if you could solve the lantern problem and record your solution, so you basically have to explain how you got your answer. You have to record what it is that you're doing and how you got your answer. I will give you extra credit, okay? And a good amount of extra credit. So the last question, and so I'm going to release all of those to you right now. So you could see all of the questions on Desmos. The last question is the lantern problem. If you could solve that lantern problem, man, you have a great understanding of related rates. That means that you are amazing at relay rates and you are doing well with it. And I will give you some extra credit if you can explain it to me. If you could explain it to me, video yourself and explain it to me, I will give you some extra credit. And then once again, your FRQ will be one of these questions on this Desmos lesson. So if you go through all of those relay rates on Desmos, it will be one of those questions as your FRQ, okay? So I never do that, but I'm doing it this time. You know exactly what the questions are gonna be, or there's gonna be one, I'm gonna choose one of them. If you know how to do it, you should be able to get 100%, okay?
Is it going to be only from day 3 or saying from all the days?
It'll only be from day 3, this one. All right, guys, otherwise I will see you on Monday. Take care, have a great weekend.